Hello everybody, this is Jeff Jenness again, continuing our lecture on geoprocessing, models and environments, and automation. Last video we talked about basic geoprocessing, showed you what all those geoprocessing tools were, showed you how to use some of the more common ones. Today we're going to move on to environments. Environment settings just give you more ways to run these tools. So let's take a look. Now all tools have a certain number of parameters you have to set in order for them to run. So for example, this buffer tool, you need to set the input data set that you're going to buffer. You need to set the name of the feature class you're going to create. You have to set the size of the buffer, and there's several characteristics you set about the type of buffer you're going to create. There's a lot of options when you're creating buffers. Now all of these are tool parameters that are required in order to run the tool, but there are actually a whole lot more parameters that you can set that affect how the tool runs. They're not necessary to set, but they're available to you. These are called environmental settings. Now there are a lot of environmental settings available. You open up the little window and you see this list here. All of these well, it shows you all the environmental settings you can set every time you open this window. Not all tools will honor all of these environmental settings. Some of them are really specific to particular data types. For example, here I'm showing you the raster analysis environmental settings. Well, if your analysis is being done on a vector data set, then it clearly wouldn't care about the raster analysis settings, so just ignore those. If you're curious about what environmental settings any tool will honor, you can find it in the Tool Help window. You open the Tool Help window, you scroll down to the bottom of the page, and you see this section on environments. So in this case, the buffer tool honors the output Z, the M resolution, etc. All these things in the list. It does not honor anything with the raster analysis functions. These help windows, by the way, are really cool. They have a lot of good stuff in it, including Python code, which I'll show you again later. Here's some really useful environmental settings, these workspace settings. You have your current workspace and your scratch workspace. Current workspace, I think, is used less often than it used to be. ArcGIS has come out with another way to let users specify where they want their data to be saved, and I'm going to show you this later. But you can still set this original workspace setting. I think more often we care about the scratch workspace. Many of the tools, as they run, they create these intermediate data sets during the process. Sometimes they might create 7 or 8 data sets while working toward that final output. All of these intermediate data sets are then deleted once the tool finishes. But the tool still has to save those intermediate data sets somewhere, and so it saves them to this scratch workspace. Now, where it matters to you is when this scratch workspace is located on a hard drive that doesn't have much space, and this has been historically the case with the NAU computer labs. It's set to a place that really doesn't have much room available, so as you're creating data, you rapidly fill up that drive, and all of a sudden ArcGIS crashes with obscure error messages. So here is the solution. You just go in here, change your scratch workspace to some place with more space, and the tool then runs successfully. The output coordinates is another really interesting and useful environmental setting. This setting lets you tell the tool to project your data into any coordinate system before it gives you the final output. So for example, maybe you want to buffer a bunch of roads, but your roads are in lat-long coordinates, but you want your buffers to be in UTM zone 12. Well, you could run the buffer tool and then run the project tool, 2 steps. Or when you run the buffer tool, you could set the environmental setting to force the tool to produce the output in UTM zone 12 using these output coordinates. It's all baked into the same tool. So the environmental setting lets you do that. Another useful environmental setting is the processing extent. This restricts the analysis to just some small region that you care about. Use this more often when you have data sets that cover a large area. Say you've got some national data sets maybe climate data. You got climate data that covers the entire country, but you're curious about climate patterns in the Coconino National Forest. So you're doing your analysis within the Coconino. There's no real point to run the tool on the entire country every time. You can just limit your processing extent to the Coconino, and then all your output is just that region, just that portion of the data that overlaps the Coke. Word of warning on this one, I have run into problems where I forgot to reset the processing extent. I'll show you that in a little bit. There actually is another interesting thing here in the processing extent. Notice there's the Snap Raster setting. The Snap Raster only applies if you're working with raster datasets and you're producing a raster dataset, but it addresses an issue that people have had a lot of trouble with when working with raster data over the years. So the idea is you start with this raster, you do some process to it, and the new raster has all the cells shifted over a little bit. And you may or may not care about that, but if you do, you get kind of annoyed with that. The deal is that when these raster tools run, they have to come up with they're producing a new raster. They have to decide where that new raster is going to be located. They have to decide where the origin of that new raster is, and then they just build the rows and columns from that origin. Now, if that origin doesn't match the origin of the original raster, then the cells wind up slid over like this. May or may not be a problem when you do a single tool, but it can be a problem when you're doing several functions in a row. If it slides this much with one run of the tool, will it slide that much again with the next run? And eventually, who knows where the rasters get slid over to? You really lose a lot of spatial precision when you do this. Now, this issue is shifting raster datasets when you analyze them. This is an important issue, and I'd like you to understand what's going on. So let's do a quick demonstration. In this map, I have loaded up some climate data showing the mean temperature, and this happens to be temperature of January of 2014 across the United States. And if you're interested in this kind of stuff, by the way, I got this from the PRISM dataset at Oregon State University. PRISM's really great climate data. You can get it monthly and daily back to the 1890s. So if you're looking for trends in weather, then PRISM is really useful. So anyway, I have this PRISM data set. It covers the entire United States, but maybe I'm only interested in the Coconino National Forest just down here. So when I do my analyses, why would I want to also analyze data in Maine and Florida and Washington? Why it would be nice to be able to restrict my analysis to just the Coconino. So I might want to clip this raster to just the Coconino. Now let's zoom into the Coconino so we can see closely what's going on. Here you can see the individual raster cells that underlay the Coconino. If I wanted to clip this raster to the Coconino, I prefer the extract by mass tool, so I'd load that up. I'd drag in my PRISM raster here. I'd pick the Coconino as the region that I'm going to extract it to. In this case, I'm going to save it to this particular location. Hit OK. It's a fairly quick tool. Runs, it creates this new raster, and now I have extracted my PRISM data to the Coconino National Forest. All seems well until you start to look closely at this raster. So if we zoom in on some of these raster cells, just zoom into this region, you can see how my new raster, the black and white, do not exactly overlay the original raster. Now I can confirm that the raster cell values got transferred properly. I can use my Identify tool. I can click on this. I've got my Identify to tell me values from all visibles layers. So if I click here, it'll tell me the value of this raster cell plus the underlying original raster cell value. I click on that, I see that I get the same value for both cells. So I'm confident that the values are transferring over okay, but they just don't line up the way they used to do. Now this can be a problem, especially if you're starting to do more than one function on this raster. Maybe the next analysis I do will shift the raster over even more. So this is where I am happy to have that Snap Raster function. So I'm going to zoom back to the original extent. I'm going to turn this one off. We're going to rerun that tool, extract by mask, pick my raster, pick my coconino, but now I'm going to set an environmental setting to snap the raster. This is in processing extent, snap raster. I pick the original raster. This means that my new raster, the raster cells will align with that original raster. So I pick that. Now I hit OK again. It runs, and now my new raster correctly lines up with the original raster. You can see the cells line up correctly now. So this is a really handy function, and boy, I use it all the time. Here's a scenario that's closely related to the snap raster. And suppose I want to do an analysis that involves more than one raster dataset, and it's going to produce a new raster dataset as an output. Maybe I want to do this example. I'm looking for areas that are greater than 7,000 feet and greater than 30 degrees slope. There's tools that will give me a new raster that shows me those regions that meet both criteria. A really useful tool. No real issue with the tool itself. But what if the original rasters, the elevation and the slope raster, had a different resolution? Suppose the elevation raster had a 30-meter resolution and the slope raster had, say, a 90-meter resolution. What will the resolution of your new raster be? Now this is a question. There isn't an obvious answer, and there isn't really a right answer. Turns out that you have a choice. And this choice is presented to you in the raster analysis environment. So in this case, if you look in the raster analysis section, you can set the cell size of your analysis, so it can be the maximum of inputs, meaning it'll be the largest cell size of all those data sets that went into it. You can also use a minimum of inputs, or you can specify a value. The mask parameter is something that clips your output to some region you care about, and this might save you a step. If you're going to do the extract by mask later, you can just bake it into the tool here. Now, environments only apply to tools and models. They don't apply to all the commands on the toolbars. So if you're looking at ArcMap and you're wanting to click on one of those commands, these environments don't apply to those. They're only to the tools. So, for example, if you're back here in ArcMap and you want to open up some tools, maybe you're interested in the 3D analyst functions, you open up your 3D analyst toolbar, you see all these nice little commands that let you do cool things. Well, these environmental settings do not apply to these commands. They only apply to these things over here in ArcToolbox. Now, here's a complication with environments. You can set them in multiple places. You can set them in ArcMap in general, so the environment applies to all tools. You can set an environment in a tool itself. You can also set them in models and individual functions within the model. So there's actually 4 places where you can set an environment. Now, what happens if you set an environment in one place and then set another environment in a different place that conflicts with the first one? Well, this is what all this is going to address. Now, let's look at these 4 levels at which you can specify an environment. First off, you can specify an environment in ArcMap itself. It's stored in the ArcMap document, and if you do it here, then all the tools that you fire up will use those environmental settings. You won't have to go into each tool environment setting and set it. Second level is in the tool itself. You double click on the tool, you open it up, you can set the environment settings within that tool. Now, understand that if you do this, it will override anything that you've set at the application. So if you set the ArcMap to produce all output in UTM zone 12, and then you open up a tool and tell it you want this tool to produce output in Albers equal area, well, the tool environment setting will override the application. Thing is, it will only last for a single run of the tool. Once the tool is done, it'll forget it. It'll revert back to the application level settings. Now you can also set it for a model, and we'll talk more about models soon, but if you build a model, you can set an environmental setting that will apply to all functions within that model. Or you can go into each individual function and set environmental settings for each one. If you do this, it will override the model level settings. Now, let's look at how to do it. First, the application level model, you do it within ArcMap. You go to the Geoprocessing menu. You scroll down to find Environments and click on that. That will set environmental settings that will apply to this map document. If you save your map document and open it later, it will still remember those environmental settings that you have set. Now, I wanted to give you a warning about this because this caused me a lot of grief a few years ago. I was analyzing some fires in Arizona and New Mexico. Here we see the Wallow fire in Arizona, and then the Miller fire in the Gila down on the right there. And I was spending a lot of time on each fire, so I spent a lot of time working on the Wallow fire, and I set all these environmental settings to make it work better for me. Specifically, I set the processing extent to only work with the Wallow fire region. So when I brought in fire data or roads or climate data, it would only analyze that within the Wallow. I saved my map document, and then later on, I opened up the same map document to start working on the Miller fire in the Gila, and every function I did, the tool would say it ran successfully, but it would produce no output. It took me quite a while to figure out that my processing extent environment setting was still set for the Wallow, and so all this Gila data I was working on, it just didn't exist over in the Wallow, and so it was getting clipped out. So I just reset the processing extent for the Miller fire region, and everything worked fine after that. Now here's another application level environmental setting. This isn't actually set within that environments window, but it is an application level environmental setting, and that is the default geodatabase. I showed you earlier that you can set a workspace environmental setting, but I told you that ArcMap had shifted to a little bit different strategy, and this is that strategy. Now you can right click on any geodatabase that exists on your hard drive. You can right click on it and declare make default geodatabase. And this is nice because every time you run a tool after that, the tool will default to saving the output to that geodatabase. It saves you time having to search through your hard drive every time you run a tool, and as long as you remember to set it, it can help you just because you can never remember where you save data. If you set this default geodatabase, you always know where to look. Now let me give you a quick example of what this means in ArcMap. So ArcMap always has a default geodatabase set, so when you run a tool, it'll offer to save the new output into that default geodatabase. When you initially open ArcMap, and if you open up your catalog window, you'll see the default geodatabase listed. In fact, there's a little button up here that if you click on it, it'll take you to that default geodatabase. Now the question becomes, where is that on your hard drive? Later on, if you want to load up a feature class you created, where do you find it? Well, the default is usually located in kind of an odd spot, so it's usually on the C drive on the installation folder in your users directory. So it's there but hard to find. Now in the NAU labs, I think they've recently switched it to somewhere on the X drive. But again, if you don't know where it is, you're kind of stuck later on when you want to get your data out. The consequences of a default geodatabase are that if you open up a tool, any tool, I'm not actually going to run it, this is just demonstrating the output location by default goes to your default geodatabase. So in this case, it's going to this long path here. Well, like I said, you forget where that is, and often it's much more convenient for you to set the default geodatabase yourself, so every time you run a tool, you know exactly where it's going. So in this case, I have a geodatabase I've created for creating these videos here. I want to make this sample data folder geodatabase to be my default. All you do is you find your geodatabase, you right click on it and say make default geodatabase. It gets that little yellow house picture, and so now this is the default. If I scroll up to the top, this thing is not my default anymore because it doesn't have that little house picture. I click my little go to default, takes me back down here. Now, consequences are that I run my tool, I drag over my feature, and lo and behold, it is now offering to save it in the right place. So that's all the default geodatabase does. I can still change it if I want. I could send it anywhere I want, but by default it puts it in the place I want to keep it. So that's the default geodatabase. Now, with these last few slides we've been discussing application level environmental settings, meaning that they're saved in ArcMap itself, so every time you run a tool it defaults to those environmental settings. Now let's move on to the tool level environmental settings. Understand well, you get to this by opening your tool and then you look at the little button on the bottom that says environments. You click that, takes you right to the environments window we've been seeing so far. Most important thing to understand about the tool level environments is that they will override the application level, but they only last for a single run of the tool. So if you run the buffer tool and you set some environmental setting, it'll do fine, but the next time you run the buffer tool you would have to reset that environmental setting if you want it to work the same way again. Now the third level is at the model level, and like I said we'll look at this soon, but if you happen to have any application level settings set, then or even tool, well, the tool settings, they only last for a single run of the tool anyway, but the model properties will override the application level settings, and we'll see this in detail, but once you open up your model window, you just hit the model menu item, scroll down to model properties, you get the exact same set of environmental settings. You might notice the window looks a little different, but it's the exact same set of environmental settings, and it's the same, all the same options within each of those. Finally, the last hierarchical level is at the model process level. This means you've opened up your model and you're actually wrestling with individual functions or tools inside that model, and you can set individual environmental settings for each one. When you do, they override the model level process, the model level settings. Now you right click on the function, go down to properties, and it's the exact same set of environmental settings. Now let's think of the consequences of these, and I have 4 questions here for you to consider, and these 4 questions will also be on the homework, so make sure you understand what's going on here. So let's consider a scenario. We have a Coconino Roads feature class. That feature class itself is in NAD83 UTM zone 12 coordinates. Now we want to run the buffer on them, so we run the buffer tool, we generate buffers. We have not set any environmental settings anywhere. After we run the tool, what coordinate system will the roads be in? So consider this. The buffer tool will buffer those features. We haven't set any special instructions, so wouldn't it be reasonable that the output would be the coordinate system of the output would be the same coordinate system it started in? And this is correct. Now let's add a complication. Now we have set our application level output coordinates environmental setting to be a different coordinate system, in this case North American Lambert conformal conic. So now ArcMap is set to convert all tool outputs into this coordinate system. We load up our Coconino Roads, they're in NAD83 UTM zone 12. We run the buffer tool. What coordinate system will the new buffer feature class be in? And the clue is that we've set an application level environmental setting. So hopefully it is obvious to you what the coordinate system of the new feature class will be in, because application level overrides whatever the original coordinate system of the data we're in. Question 3. Again, we set our application level environmental setting to North American Lambert. Our rows are still in UTM zone 12. We run the buffer tool, but this time in the buffer tool we set the tool level environmental setting to be a different coordinate system. So the roads themselves are in UTM zone 12. The application is set to produce all data in North American Lambert, and then we set the tool to produce the data in a Web Mercator auxiliary sphere. Then we create our buffer. Question, what coordinate system will the buffers be in? Okay, so think through this. We've set an application level setting and we've set a tool level setting. Remember that the tool level setting overrides any application level setting. So it's going to be in the setting we set for the tool. Next question, closely related. We've set our application again to North American Lambert. The roads are still in UTM zone 12. We open the buffer tool and we set the tool level coordinates to the Web Mercator. We run the tool. But we open the buffer tool a second time, and this time we don't set any tool level environmental parameters. We generate our buffers. What coordinate system will the second road buffer feature class be in? So this question is getting at the how long the environmental setting lasts. Remember that when you run a tool and you set an environmental setting for the tool, that only lasts for a single run of the tool. After that, the tool reverts back to the application level settings. So we run the tool a second time, it's going to be reverting back to the application level settings. And so hopefully you see the answer in this slide here. And that's what I'd like to say about environments and the hierarchy of environmental settings. So I think we'll close off this video here. The next one we'll pick up with Model Builder, which is a really clever and easy way to string multiple tools together. It's a really cool function, so I think you'll enjoy it. Thanks so much.